Okay, people, let's get started. I don't think this is on. Yeah. Yeah, there it goes. All right, so I want to get started today. So the one thing I want you people to do is to limber up your mouths because I want you to talk during this class. I'm going to try to lay out the sort of data-driven case for for what I think will inevitably your uncertainty about issues that are ethical, that are unanswerable just from the contemplation of data, all right? And so I'm going to want to, I think there are 2 points during the lecture when I'm going to want to have a bit of discussion. And so we're going to be passing mics around, and we're going to go slowly, and everyone is going to talk loudly into the mic as though you were a rock star, right? Rather than sort of far from the mic and quietly, and so on, okay? So the question is, who caused the climate problem, right? And we have 2 different fat cats here. Who's responsible for and has thus benefited most from fossil emissions? And this is the critical issue. What is a fair way to assign responsibility? And what I want to do is to talk about responsibility, not because I'm an expert on it, but because of the opposite. It's why there's an ethics portion in this course, and it underscores the need for ethical concerns. Because if you try to think your way through the solution of any one of these global nexus problems, you very quickly come up with imponderables that are impossible to answer from the confines of an individual discipline. Certainly I find this impossible from the confines of science, and economists should find it impossible to understand from within the confines of economics. Now, the first thing I want to do here is to remind everyone of what the current picture is. Fossil emissions of CO2 are the single biggest problem in the climate problem that we face and that we have to get under control. Most of the emissions to date, 2/3, most of the warming is caused by previous fossil emissions. And in the future, the share of the warming, if we don't get this problem under control, that are caused by CO2, as opposed to other greenhouse gases, just goes up and up and up and up. And the share of CO2 that was caused by fossil fuel consumption, as opposed to land use, just goes up and up and up and up and up. Not too many years ago, like 5, this number was 80-20, and now it's 87-13. And it's because the fossil emissions continue to go up, whereas the land use emissions stay approximately the same. The level of deforestation is approximately the same, and we'll discuss why that's the case. It's still the case that the level of deforestation, for instance, goes up in individual years, but on a global average, in many countries, it's going down already. And so there is also this issue of the natural sinks, but we're primarily going to be focusing on the left-hand side of this story. Now, this graph, this bar chart from the World Resources Institute shows which nations are responsible, and this is in 2011. This is much more true today, but this ranking is still the case. It's still in force today. Which nations are currently the most responsible for fossil emissions. And the thing I want you to look at here is that the total emissions excluding LUCF, that's an acronym for land use change and forestry. So that's the forest part as opposed to the fossil part, okay? And you can see that most nations like China, if you include land use change and forestry, their emissions are actually a little lower. And in the United States, their emissions are actually a little lower. And in the European Union, their emissions are actually a little lower. And that's because of this side over here. There are sinks in those nations. The natural sinks are bigger than the natural sources, all right? But it's pretty small potatoes, right? It's that little change for China as opposed to the big one. Turns out to be real in China. The Chinese planted a gigantic number of trees. You can verify it with a satellite record. It's a tractable problem to do in an undergraduate summer for a thesis or a junior paper or something. No question about it. They've done this, and they piled up a bunch of carbon on their land, and so there's this small reduction in Chinese net emissions from land use change. The United States has a big regrowing sink, most of it east of the Mississippi, from abandoned farmland. European Union and so forth. Now notice Indonesia and Brazil, where it's the opposite direction. And these are, of course, the countries at the epicenter of deforestation concerns. Brazil right now is in the news because of the burning Amazon and the populist president of Brazil who reversed his previous policies, but that now has been forced by international condemnation into trying to do something about it. And Indonesia, this big land use change emission is caused primarily by the conversion of Indonesian rainforest into palm oil plantations. That's something that's incredibly lucrative. The net present value of a hectare of rainforest to an Indonesian poor person is about $15,000 US, which is a transformative sum for a single hectare. On the other hand, that land also, a lot of it holds peat, so there'll be meters of peat underlaying it. It's a weird combination of a tropical rainforest on a layer of peat that you would normally associate with like Northern Ireland or the far north. But nonetheless, when Indonesia burns, as it is doing right now, the soil burns as well, and you get this massive amount of carbon returned to the atmosphere. So these nations tend to be really preoccupied with land use and land use change. And this is true of many poor, primarily tropical nations. And that causes, in some way, the land use change and forestry to carry disproportionate weight in an international negotiation for two reasons. One is that you have to bring those countries along, and these are the issues they care about, all right? So they're going to get screwed if they're responsible for all of this, right? And the other reason is that a lot of other nations would like to buy the reduction in that rainforest burning. So that, for instance, even in Indonesia, where a hectare of rainforest is worth $15,000 to a local landowner, it is also the case that that land has peat on it, and so there are typically 5,000 tons of carbon in a hectare stored in a hectare of Indonesian peat forest, almost all of it in the soil. And so if you were to buy that if you were to buy all of that 5,000 tons of carbon, you'd only need to pay $15 a ton, right? I'm sorry, $3 a ton to get to $15,000 and beat the other value, you see. And that's $3 a ton for carbon. CO2, as you know, you get a lot more CO2 out of carbon than you get out of carbon. It's, remember, 44/12. And so the point is, it's a tiny fraction of a dollar for each prevention of an emission of CO2. And so there's all kinds of nations that instead of reducing fossil emissions would like to buy up Indonesian rainforest and say, see what we did, right? So there's some very difficult and interesting ethical concerns here. But I just wanted to flag this before going on, because we're going to be talking primarily today, not about these nations, but about these. Okay, so this you've seen before. This is the current trajectory of global anthropogenic emissions, and you know, it's still going up, right? That's the problem, still going up. Sometimes it goes up a little slower, but then it picks up again, and nobody's going to say that this trend over the last 20 years is anything other than unchanged over the long haul. There's no strong evidence of a slowdown. If you look at oil, gas, and coal, we have heard a lot about the demise of coal. It is certainly true that in developed nations, Coal is very much going extinct, and rapidly, because it's more expensive than natural gas and renewables. But globally, there is a large, still, expansion of coal that almost compensates for the reduction elsewhere. So Chinese and Indian expansion of the use of coal to try to bring electricity to their poor populations is more than enough to, well, is almost enough to offset. You see there's this little drop here, a little tiny tick up at the end, but it looks like coal use globally has stalled. That's because of the difference, small difference between two big terms. Massive growth in emissions in some parts of the world, really the developing BRIC economies, and contraction in the rest of the world. I was speaking to the government in China, and the head of one of their big oil and gas companies came up to me to defend coal use in China. And she's a really high-ranking CEO now, but she grew up in the northwest of China in an unbelievably impoverished family. And she related the story about when she was a young girl. Her job was to go out and try to find discarded coal that had fallen off railroad cars to try to keep the family warm in the wintertime because they couldn't. So it was freezing in their house. And one day she came back and her mother was passed out and hypothermic and she thought she was dead. And she said, no one in my country is ever going to have to suffer an experience like that again, right? How dare anyone say that we're not allowed to use coal? And it's a pretty compelling argument, I've got to say, right? Okay, so this is coal use. Oil is still on the way up. This is a dead fuel walking, though, with the electrification of the light and medium-duty vehicle fleets becoming, I think, inevitable for technological reasons. Gas is ascendant, and really this is the primary, this is a pivotal point in the negotiation about what we should do about climate in the future. Should we invest in this fuel as a bridge because its emissions are less than coal's, or should we bypass it altogether somehow? But you can see there's no picture you can take from this that is reassuring and warm, right? This still looks like onward and upward. Okay, so I want to talk a little bit more about who does the emitting that caused the problem. And this is an entry point to a discussion about responsibility. I want to show you 4 different ways to rank emissions. When you start searching for what's the right way to apportion effort, this is one of the first things that data-driven people do. They go on a website somewhere, they look at global data, and they start to think, well, let's look at different ways to do it. And these are the ways, right? You can look at the national emissions. You can look at national emissions per capita, right? You can look at national emissions per unit of GDP. And you can look at the cumulative, that is the historical national emissions. Those are all different ways that you could rank who does the most emitting. So if we look at the top 4 emitters currently, as I just showed you in a previous slide, but I want to show you this sort of current data because there's a bunch of graphs that are all from the same source here. China is the biggest emitter by approximately a factor of 2. Followed by the United States, followed by the EU, which we're leaving as an honorary country right now, with Britain still in it. And India is down here, not in 4th place, but soon to be number 1 or 2, right, as India develops. And so these are the big ones. There are some other big ones, but these are the really big ones right now. So China, by this measure, would bear the most responsibility. It's doing the most current damage. The United States second, the EU third, and India is struggling to increase its responsibility, but doing that successfully, right? All right. So this is the picture if we look at emissions per capita. And the US, as always, we're number 1 here. And notice that we're approximately 3 times the per capita emissions in the EU, all right? And that's a pretty interesting number, all right? That's a big gap. It's 2, maybe let's call it 2 times. But still, the Americans per capita have double the emissions that a EU person does. Now, this is tons of CO2 per person. And so it's really worthwhile to remember what this means. The average person in the United States emits 17 tons of CO2 per annum. Think about what 17 tons of anything looks like. That's like 5 Cadillacs, all right, worth of emissions. That's a lot of stuff that our lifestyle is putting into the atmosphere. China is already tied to the EU. The world is down here at 4.8, and India now is still at 1.8. An enormous population, a gigantic number of poor people, and so the per capita emissions are quite a bit lower. So this is the emissions per unit of GDP, and this is a metric favored particularly by the developing world. And what you see here is that the Chinese emissions per unit of GDP falls monotonically. Now this is a measure that nations tout as being a marvelous achievement. They say this is often called emissions efficiency, right? So how much wealth do you generate per unit of emissions? And notice how much progress the Chinese have made. As we'll see, I think this is a false equivalent. I think emissions and wealth have been decoupled for a long time. Oh yeah, go ahead. Yeah, so the question is, do we want that to be going down? And the answer is the smaller emissions are per unit GDP, the less we emit per unit wealth. If we achieved net zero as a species and maintained economic growth at the current rate, that would fall to 0. Yeah, so the Chinese and their NDC, their commitment to the Paris Agreement, stated the first one in terms of this number, this so-called emissions efficiency, and they said they want to further reduce it. All right, and the thing is that every nation, as they industrialize, that reduces, and it's because wealth grows faster than emissions. Typically, wealth grows faster than emissions. You eventually buy all the stuff that does the emitting, and then you just buy like fancier versions of the same stuff. That's what happens, right? So you can see that the US by this measure is still near the top, but it's actually a little less than the world average. India is surprisingly close to the rest of the world. China really is an outlier, but the EU here looks like a champ. And so that's yet another one. And this is one favored, again, by developing economies because it's a number that they believe they can drive down as their population becomes wealthy, which is their primary goal, lift people out of poverty. And their emissions don't rise as much as their wealth rises, as their earnings rise. And this is a final measure. This is the proportion of cumulative global emissions. So the width, the size of this blob here determines who's emitted the most in the past. So this is each year, the fraction of global emissions, of total emissions grows this way. And what you can see here is that the EU is the largest historical emitter and the US is second. And so currently, this is in 2016, the EU and the US were just about tied in terms of their fraction of global emissions, collectively responsible for about half. The EU because they were the first into the Industrial Revolution, and the US because we were the biggest emitter through most of the 20th century. China is now picking up with historical legacy of past emissions responsible for a substantial fraction, like 10% of all historical emissions. India is still tiny. Japan is still tiny, and so on. So this is really, these numbers here are the numbers that determine who's responsible for the current level of climate change, all right? What fraction of the CO2 that's in the atmosphere that's in excess did you put there as a nation? And finally, a lot of times people want to talk about the fact that the developed nations typically buy a lot of energy-intensive things from developing nations. And the ones that are currently developing the most rapidly have the cheapest labor times the industrial capacity. China's the prime example. And so we're constantly importing stuff that took energy to produce, and we're getting the benefits of a lot of that stuff, but we're assigning the emissions to China, right? Because, right? Now, on the other hand, the Chinese companies sold that, and they got the benefit of the money that we paid for it. But there's an ethical question about whether or not the emissions ought to be assigned to those that produce the goods. In other words, where in the world did the emissions actually come out of the ground and into the air from? Or should they be embedded in the services that people demand, the goods and services that people demand when they make purchases? And so do you own the emissions in the Chinese article of clothing that you bought, right, that was made out of petrochemicals, or do the Chinese own that just because it went up there? And this is often talked about in terms like it's really thorny, and it is sort of, but these numbers here show the gap between consumption emissions and production emissions. And notice that Chinese emissions fall substantially if you embedded them in the goods as opposed to in the production. In other words, if you assigned the Chinese manufacturing goods embedded emissions to the countries that bought them. They rise a bit for the US and the EU, fall a bit for India, as you'd expect, but notice that the gaps between the dashed line, the consumption emissions line, and the production emissions line just isn't that big. So to zeroth order, this is a second order sort of concern. It's an important thing to think about, but it's not, in my view, primary in establishing responsibility, simply because this gap isn't nearly as large as other gaps between countries, right? So the gap between Chinese current emissions and US current emissions is much larger, is large whether or not you look at consumption or production emissions, right? And the consumption and production emissions lines within any one country are small relative to the inter-country differences. Finally, although we talk about this as a developed world problem, and certainly historical emissions from the developed world caused this problem disproportionately, current emissions from non-OECD countries, the developing countries, the poor countries and the developing countries, exceed OECD country emissions by a lot. So the current making the problem worse collectively is much more centered in non-OECD countries than in OECD countries. This graph is complicated, but it shows GDP per capita, how sort of wealthy people are, versus energy consumption per capita. And you can see that in broad strokes, as you get rich, first, not a lot changes, and then there's this rapid period at which basically you attain the developed world lifestyle, and emissions per capita go way up. But then in wealth terms, your emissions stagnate or even fall off. So if you look at US emissions here, they're kind of creeping down per unit of GDP, all right? And Canadian terms are approximately flat. Germany, same thing, creeping down a little bit. UK, almost flat. So once you get up into this range, everything sort of stops. And the amount of emissions generated per unit GDP, extra emissions generated per unit of extra GDP is zero, all right? Now that's not true entirely, but when you think about it, when you attain a certain level of wealth, the average person buys a car, starts burning fossil fuel in the car. They have fossil fuel heat in their home, either from electricity or by directly burning it. They have a home that they're heating and cooling, and so on. And basically that carries them up into the lifestyle of a developed world person. Now, as they become more wealthy, their style of car goes up, but the amount of miles they drive typically doesn't. The size of their house goes up, but the amount of energy that it takes to heat it doesn't double as the size of the house doubles, and so on. Now, when you get ultra wealthy and start buying airplanes, then that's a different story, all right? Aircraft really suck the gas down. And so when you get into the fabulously wealthy and get into personal aircraft, that's a different story. But by and large, this thing kind of levels off, all right? That's sort of good news, but it levels off at a high number. This graph shows the population ranked in terms of the emissions that they do cumulatively. And the way to read this is as follows. Here, at this number, 3.2 billion people emit a total of about 12 gigatons of CO2. The 3.2 billion lowest emitters collectively emit about 12 gigatons of CO2. All at the time this was put together for the shockwaves report for the World Bank, the 6.5 or 6.7 billion people collectively were at about 28. Now we're considerably higher than that for CO2. But notice this number here. The lowest billion people are responsible for much less than 1% of total emissions. So those people are too poor to afford anything that emits, all right? Now these are just done with national statistics. Each one of these blocks is a block that represents an entire country. It doesn't break it down by level of individuals. We'll look at graphs that do later. Within each poor country, there are rich people who emit a lot and poor people who emit nothing. But it still shows the desired result, the important result, that here, the lowest billion people, the poorest billion people, the lowest emitting billion people don't emit anything, right? I mean, they just emit nothing. To a first approximation. So get out your clickers. And I want you to talk a little bit to consider the principle or concept of fairness that would justify a difference between commitments of developed and developing nations. So if we're going to solve this problem, who's responsible for doing it? What quantity should be used to set a nation's nationally determined contribution, which is the jargon that we use in the Paris Agreement? How much should we expect countries to do? And what should determine how much we expect them to do? So the first one is a nation's population size. Should population size count or not? So yes or no. And just click it really fast. And then I'm going to ask somebody, or a couple of you too, who voted yes or who voted no, to respond. So finish it off here, and I'm going to stop it. And there'll be plenty of times to vote if you haven't voted yet, so that you'll get credit for voting. And the answer is it's 70% yes, population size counts, and about 20% no, and a bunch that said D, which is neither yes nor no, I guess, I don't know. So can somebody who voted no tell us why they voted no? Don't be shy.
Certainly, the population size already figured into the total emissions because more people are going to end up, more than fewer people are going to.
Yeah, so the issue there is that in some sense we owe it to people to allow a certain level of emissions. And just because they happen to be born into a populous country doesn't mean they should, in some sense, suffer, right? Is that right? Like that? Now, who voted yes? Somebody who voted yes, explain it. Okay. There are a bunch of almost raised hands here. I think there's one down here, there's one there. Yeah. Yeah, so that's where population size really ought to matter. When you say no, your response that you explained as no is consistent with the response that was yes. So does somebody have a no that means no, we shouldn't allow populous countries to claim a larger emission than countries with a small population size? Does anybody want to defend that? Well, let me defend that. I'm going to defend it as a political deal. This is a deal among nations. The problem is a collective deal. Nations are playing real politics. It's the only way to get the deal, right? It's the only way to get the job done, right? That I think is the answer, right? That I think is why. There is some attention paid to population size, but not disproportionate attention paid to population size, so that in the negotiations, there is no sense in which the U.S. comes in a position that India, with 7 times the population of the U.S., is going to be allowed 7 times more emissions, right? Like that. Okay, so kill this. And the next one, the nation's historical emissions in addition to current emissions. Now, we'll remind you that the Paris Agreement is about current emissions and future emissions. It's not about the legacy of past emissions. Those that have a legacy of past emissions have no commitment over and above what their current emissions are than they should. So who thinks that yes, a nation's historical emissions should matter, and who thinks that they shouldn't matter? So yes and no. Okay, let's kill that and see where we are. And again, it's 70-30. This turns out to be a universal constant. So the majority of you said that, historical emissions ought to matter. Who wants to defend that? Somebody? Yeah, it does. So who's got a no? Right behind you. Just hit it one back, and then we're going to get further back in the room next time, okay?
I don't need to blame the first to the party. And the community working at the future, we didn't know 50 years ago that we were talking about driving complaints around, we didn't know where that was.
Yeah, so these are all really important concerns. And I'm going to lay just 2 other things on you that we're going to discuss later. On the one hand, when a citizen of the United States becomes a citizen, so let's suppose they come from a poor country and they sign the citizenship papers. On that day, do they somehow assume the responsibility of U.S. historical emissions? So that's the first question. The second one, we'll talk about that more later. The second one is the Industrial Revolution, which created, for better or for worse, what is called the good life, was purchased with fossil emissions, all right? And so in some sense, is that bad? And should countries be given an allowance to build the infrastructure that is consistent with that sort of good life? To build the roads and the housing and all that sort of stuff. That takes a lot of emissions. Chinese had a big bulge in their emissions when they built all of that stuff that you can see in China today. And so I think, obviously, there are, you can argue both sides of this coherently and rationally. And these are ethical concerns. These are not concerns you're going to work out just with evidence and logic. Whoops. Third one, a nation's current GDP. Should that matter? Okay, I'm going to kill it. We don't have to do this anymore. You know, everybody has the idea that the wealthy should do more and the poor should get a chance to build the infrastructure of the good life. I think that's what most people believe. Anybody who voted no, you want to defend that answer? Excellent point. So this shortchanges poor emissions or poor countries that are populated with lots of people. Okay, I'm going to just skip through the remaining because I'm getting behind here. A nation's total wealth independent of current GDP. In some sense, that wealth was built largely with a legacy of past emissions. And so wealth, as opposed to earnings, right, as opposed to economic activity currently, which is GDP, is more closely tied to the historical emissions than it is to current emissions. So that's like the first two there. And the nation's infrastructure assets. I already said that does a nation have a responsibility to provide the infrastructure of a modern developed world life to its citizens? Okay, so let me move on here. We've already known that, we know that to achieve a Paris emissions reduction, it's below 2 degrees C, developed nations are going to have to get 100% cut by 2050, and developing nations 100% cut soon thereafter. But remember, there will still be ongoing CO2 and non-CO2 greenhouse gas emissions because we don't know how to eliminate them all, and we're going to have to compensate with negative emissions. And so when we talk about emissions into the future and emissions cuts into the future for the remainder of the time I have with you today, keep in mind that that is consistent with 100% cut in net emissions. It's because some emissions keep going and are offset by negative emissions. Okay, so here's a little diagram. Before, when we just had this little set of questions, the concept of fairness and responsibility that we're using were centered on the responsibilities of nations. Should a nation do this, and should a nation's commitment be that? Does a nation have the responsibility to build something? And in most of your lives, I think you think about an individual's responsibility. What is an individual's responsibility for doing something? And so, although no one's ever done it in an international negotiation, you could, in principle, build a nation's responsibility from individual emissions, from individual responsibilities. You could sum them up. And so this is a little scheme to do so. Let's suppose that we took everybody in the world and we lined them up from the lowest emitter to the highest emitter. What would that look like? It turns out it's possible to do that. And if you were to do it, and then we're going to make this cumulative emissions, so we're going to add this guys to this one, and those two guys to this one. So this curve is going to go up, the cumulative emissions of all the people, all right? But these people are ranked from lowest to highest emitters. Everybody got that? Okay. And that's what the curve looked like in 2003, the only time this has been done to my knowledge. And so there were 6.25 billion people in the world, and that's what it looked like then. And the interesting thing was that if you look at the bottom half of emitters, they're responsible for 7% of the total emissions, with 93% caused by the top half of emitters. And so that really means that the problem of international development and the problem of climate change are almost separable problems. The poor can't afford anything that does very much emitting. All right? That's the first problem. Yeah. Second thing is that the highest 10% in terms of emissions are responsible for half of the world's emissions. And the amount of emissions that somebody has, you can see that arrow there corresponds to 1/10 of a ton, a half a ton, and 2 tons of carbon per year, corresponds very tightly to the person's income. So a person that earns $1,000 per year emits 1/10 of a ton, and a person who earned $30,000 a year per capita emitted 2 tons. And so the 10% of the richest people in the world are responsible for half the problem, okay? Because we're the ones that can afford this stuff. And in fact, when you graph the cumulative population in billions against the total for wealth and emissions, the two curves are right next to one another, okay? And that just goes to show you that this is really all about wealth. And so at least in principle, we could say, look, we're going to sum the emissions of everybody in the world, of everybody in a country, and we're going to say what would the individual emissions cap have to be to meet some global target, and then say that everybody in a country who's over that needs to cut down to that cap, right? And you could then assign national caps by looking at who individually was over their sort of personal allowance. So you could in fact build up national emissions responsibilities from individual emissions responsibilities. I'm not going to do this. This slide, you can look at it later, is about the difference between doing this based on income versus wealth. You might think wealth is a better measure of personal emissions, and it turns out it is, but it has some sort of paradoxical attributes. So if you shift from income to wealth, it tends to penalize poor countries, because it turns out there's some really rich people in poor countries. Okay, so here's the second set of clicker questions. We don't have much time for these, but I want you to contemplate these questions. What factors should determine your individual responsibility to pay for emissions reductions? So you as a person, what should determine it? So first of all, let's talk about wealth, your wealth. Every dollar has robber baron roots, okay? And was built. All the wealth that your family or that you personally have comes from a legacy of past emissions. Should that matter, yes or no? Okay, kill that. There it goes again. So 75% of you said yes, 25% of you said no. I'm going to jump to the next one, and then maybe we'll get some comment back. Should it include your past emissions, including all those embedded in the products you've bought? So all the economic activity you've done as a person. Okay, let's kill that. Okay, now your income. Should your income matter? A little higher that time. Everybody thinks, yeah, if you're making a lot of money, you ought to be more responsible, okay, as a person. 83% versus 17. Your citizenship. So it's the question I posed before. When you sign citizenship papers, so you've got a poor person of Native American heritage who grew up without electricity in Mexico. They somehow win the lottery here in the United States, and they sign citizenship papers. Are they responsible because of that? No, it was the first real change we've got. 2/3 said no, 1/3 said yes. All right, and the last one. Does citizenship confer responsibility for your new nation's past emissions? So if you're a recent immigrant, are you now retroactively responsible for the emissions that happened throughout the 20th century and the late 19th century in the United States, or for the emissions if you're a UK citizen, if you're an Indian import into the UK and you've become a citizen, are you responsible for the industrial revolutions during emissions of coal during the 19th century in the UK? Okay. So 63% say no, and 37% say yes. Now, the thing I want to leave you with is that I personally don't really know how to answer any of these questions, okay? These are extremely difficult questions. Who thinks they know how to answer these questions? I don't think anybody's going to raise their hand. These are really hard issues, right? There's no amount of economic analysis, social analysis, political analysis, or scientific analysis that's going to lead you to an answer about what your responsibility is in these terms, all right? These are fundamentally due to an ethical system, and if you're going to develop one that allows you to scrutinize it and to look for inconsistencies, it's going to be in a different domain, okay? So thanks very much. See you next time.